Hello grade 9s, welcome to the day 1 video. This is your summer school teacher, Miss Malari, and I'm basically just going to go over some of the key lesson notes that are part of the 41-page document. I know it seems like it's a lot, however, keep in mind some of the documents that are within this one huge PDF are answer keys so that you can always take a look at how you're doing. And it's just really key notes that you should be looking at to help demonstrate what you should be reviewing. Okay, and keep in mind some of these notes, the reason why it's also so large of a document is this would be stuff that I would be teaching you verbally, right? Like if we were in a real classroom, I would be up at the smartboard or the whiteboard and I would be actually talking out loud these notes. Okay, so that's why it's such a big document. So I just want you to keep that in mind. I will go through some of the key important parts in this video. Okay, and in that, I'm just going to get started. So thanks for tuning in. This is the day 1 video. Okay, and I'll try to post a video every day so that you have something to look at and use for your notes while you're learning at home. So the first little bit, I just have a little discussion about languages. Okay, so this is a little fun activity you can do. Okay, and try and figure out which one's which, and yeah, you could just go from there. Just thinking about how languages can connect to sentences and just doing that matching activity. Okay. I go over in the first beginning introduction that the idea that math is just a form of a language. Okay, so when we do math equations, when we calculate, when we use certain terminologies, we're using a lot of concepts that build on over time. So right now you're completing your remedial grade 9 course. By the time you get to grade 12, you're going to have a mastery skill in mathematics, right? Because you would have acquired everything that you've learned over the last couple of years on top of the years that you've learned math in elementary school. Okay, so math is a form of a language. Keep in mind it has distinct set of rules. Okay, so for example, when we're solving equations, right, 2x is equal to 4. To show this, I would divide both sides by 2. Keep in mind this cancels, 2 over 2, so x is equal to 4 divided by 2, which is just 2. So one of my rules, you'll notice there's the equal sign that goes down the middle, kind of like that wall. And it helps create some sort of flow and understanding of how to solve equations, to when we get there, of course. Okay. Another rule would be BEDMAS. Okay, so BEDMAS, so when you are trying to evaluate, always remember you should go in the order of left to right, starting with brackets exponents, in the order that it appears, division multiplication, in the order that it appears, addition subtraction. Okay? Math is also used to communicate ideas. Okay? So for instance, your take-home pay is 60% of your weekly pay minus a $30 health benefit premium. So your pay is equal to 60% of your weekly pay minus $30. So you see that we can also take those words and put them into an equation form. So your first activity of what you're going to do is you're going to make a math dictionary. Okay, so you can do this on Microsoft Word. You can also do this in your notebook if you prefer to do this in your notebook, and if you want to take out some colors. I'm a very colorful person, so if I was in class with you, you would have been doing an activity that organized it the way that you liked it. So we're going to do the same in distance learning or e-learning. Okay, so you're going to make 3 columns. Oops. Okay, you're going to have math term in one, definition in the other, and then example in the third column. Okay, and what you're going to do in your first homework activity, this would be an example of how I want you to organize this. So for instance, a term is a portion of an expression or equation separated by addition or subtraction, and then an example. Okay, examples can have pictures, so if you want to have a picture that helps represent what you're trying to convey, no problem, you can do that. This is going to be your list. Okay, make sure that when you guys are looking this up, you're using reputable sources. Okay, so some reputable sources could be, let me see if I can look some up for you so that you have good ones. Math is Fun is a good one. mathisfun.com. Even looking up math definitions. So you could consider Wikipedia. And again, it just has to be very short, like this one. This is your example. But you have to make sure that you have this ready to go. Okay? Won't take too long. I'll just skip some of this stuff. Okay. Actually, no, I won't. So the whole purpose of talking about this at the very beginning of the course is that math does have a language. There is some structure, and there are rhymes and reasons why we do things a certain way. Okay? So for instance, when we calculate the following here, okay, you'll notice, this is on page 6 of the 41 pages. If we were to calculate it without brackets, so 1 plus 2 times 3, we would use BEDMAS. So we would do 2 times 3 first. So it would be equal on the left-hand side, 1 plus 6. And then I would just add them up, and it would be 7. But if I have brackets, like how I do in the second example, I of course have to do brackets first. So really this is saying what's 3 times 3, because 2 plus 1 is 3. And you look, I got a different answer, even though the numbers are exactly the same. Okay, so in the way that it's written definitely matters, right? Math is a language, the way we interpret it is important. So we have to keep that in mind as we're doing our solutions, okay? You can try that. BEDMAS. Okay, so as I mentioned earlier, I'll just write it out so we have it. Brackets, exponents, division, multiplication, addition, and subtraction. Okay? In the order it appears, you might notice sometimes these two might interchange depending on what comes first, from left to right. Okay. So we're going to talk about fractions. So again, I have your definition here. Fractions are used for counting a part of something. Okay, and we do this all the time. We do this when we open a bag of cookies and we count how many cookies we ate out of the total bag. We do this when we eat pizza and we share pizza with our family or with our friends. We do this every day. Okay, we may not realize we're doing fractions, but we're actually very used to calculating it if parts are equal. Okay, so where it gets a little tricky is when your parts are not equal. There's two components in a fraction. Okay, so again, your numerator and denominator. There's the fraction line as well. There are certain components that we need to associate numerator and denominator with. So for your numerator, right, if we were taking a piece of pizza, we can see that there are 3 pepperoni slices out of the 4. Okay, we can tell that there should have been a 4th slice in there. Somebody got hungry and ate it. Okay. So we can, or I can let you go through some of these examples on your own. Okay. I will, though, go over multiplying and dividing fractions. Those ones are easy, so I'm going to start with that first, and then we'll do adding and subtraction. Okay, so for multiplying fractions, it's pretty straightforward. You literally have to go numerator to numerator and denominator to denominator. Okay, you do not need a common denominator. Okay, not for multiplying fractions, not for dividing fractions. So what we would do, we would multiply 1 times 4, which would be 4. We would multiply 3 times 5, which would be 15. We see if we could simplify that. If we can't, draw a box, you're done. Okay? Same thing for what's on the right. Numerator and numerator. 2 times 3, which is 6. I can write it out here just so you can see what I'm doing. Not necessary though. Okay? If you can, simplify. Okay, so over here you can see that you can actually divide both by 3. Oh, we could even go higher, couldn't we? You can divide by 6. Okay, so that would be 1 over 5. Okay. When you're multiplying a mixed number, okay, what you might do to help make it easier for you is to change it to a improper fraction. Okay, so how I do that, I'm going to keep my denominator. I'm going to multiply the denominator with the number in front, so it's like 5 times 1, which is 5. And then I'm going to add the numerator. 5 times 1, which is 5, plus 4 is 9. Okay, so I just converted from a mixed fraction to an improper fraction. Then I'm going to multiply by the second fraction. I'm not going to change it. And my rules remain the same. Numerator, numerator. Denominator to denominator. Okay. If I wanted to simplify this, I could divide both sides by 3. This would be 6 over 5. Or, how many times does 5 go into 6 evenly? 1 time. How many are left over? 1. Keep the denominator 5. Okay. Dividing fractions. So your rule is, when dividing fractions, invert and multiply. So I'm going to rewrite the first fraction, 2 over 3. I'm going to invert the second fraction, so 5 over 4. And then instead of division, I'm going to multiply. And then like we did in our previous step, very straightforward. 2 times 5, which is 10. 4 times 3, which is 12. I'm going to simplify, divide by 2, divide by 2. So really I have 5 over 6. Okay, so that's multiplying and dividing fractions. I might also add, if at any time you think I'm going too fast, you can control my video by just pausing it, getting your ducks together, writing down what you need to write, if you're making your own notes at home, then replaying the video when you're ready to move on to the next question. Okay? Okay, fractions. So the most important thing here is before adding or subtracting, you must find a common denominator. So here we do need our common denominator, meaning your denominators need to be exactly the same. Okay? Now you can see here, fractions that went badly. Okay? So this is a no-no. This is not what we want to happen. Okay, you don't just add the numerator, you don't just add the denominator. It's not like multiplying where we just multiply the numerator multiply the denominator. You have to make a common denominator. So this is what we don't want to happen. Okay? Now, this shows you a nice little clip as to how to properly add fractions. So you could just take a little read on that. But you can see here, we made a common denominator of 15 because we multiplied the numerator and denominator by the lowest common factor. And then once you notice the denominators are the same, then you can add the numerators. Okay, so we got 7 over 15, or if we simplify that, 1 over 250, 1 over 2, 1 and 215, sorry. Okay, all right. Let's do one just so you can see it, okay? So let's think of a common denominator. So we have 1/2 added to 2/3. So common denominator I would put here would be 6. Okay, so how can I make 6 my denominator? Well, I'm going to multiply by 3 to the first fraction, multiply by 2 to the second fraction. 1 times 3 is 3. 2 times 2 is 4. I've already handled my denominators. I then can just add my numerator, and then I'm going to turn this into an improper fraction. So 6 goes into 7 one whole time with 1 left over, and I keep my denominator. Okay? Alright, you could try this one at home. I also go into a description of ratios, percents, fractions, and decimals. So this is kind of like putting it all together. How to convert between each one. Okay, so just have a read for that. And please also have a read for percentages. Okay? How to change percentages to fractions. Okay, so it gives you steps right here. Put the number in the numerator of fraction out of 100. So this would be 25 over 100. Then I'm going to reduce the fraction to lowest term. So I could divide this by 25, divide this by 25. I should be left with 1/4. I now have a fraction. 25% is equivalent to 1 over 4. Okay. Finding the percentage of a number. So remember, the word of just means multiplication, okay? But you have to change the percent to a decimal. So in many real life situations, we may want to know how much a certain percentage is. So for instance, I love to shop whenever I see a good deal. I'm always calculating how much I'm saving because that means that I got something for a discounted rate. Okay, or if I go into a store, I want to figure out how much tax I have to pay or how much tip to leave someone at a restaurant. This is how you find the percentage of a number. Again, things we do every day, we just may not realize. Okay, so sales tax, definitely in Ontario, is 13%. How much tax will I have to pay on a shirt that costs $24.99? So hopefully you know to turn 13% into a decimal. Then you can multiply that by your price of the shirt. Okay, so notice how I'm doing my calculation. I'm showing my work. I'll take out my calculator. I'll do 0.13 times 24.99. And I'm going to round this to the nearest hundredth. So this will be 3.25. Okay, I'm going to do my therefore statement because I always do this at the very bottom of any word problem. Therefore, the tax on the shirt is $3.25. Okay? Here's just a quick practice, some more rules, and things that you can read also on your own time. Okay? Okay, so please, let me see if there's anything worth going for. Okay, here starts the rest of your homework. Okay, so what you're going to do, you're going to complete these questions. Okay, so the first little part is on percentages. Okay, so just make sure that gets done. You're going to add fractions, you're going to subtract fractions, you're going to multiply fractions, and you're going to divide. Okay, this is a huge step in math. I always say fractions is the root of mathematics, and just understanding that language in those situations. Okay, don't fret. Anytime you have a whole number, remember that whole number just has a 1 underneath. Okay, and you can move on and solve it during using the steps that we talked about. Order of operations, so BEDMAS. So this just has a little note about BEDMAS. So again, these are talking points. You would just read through these examples. On page 31, this is your next thing that you'll be calculating and taking a look at. You could also check your answers down here. Okay, so you can see you have solutions here for some of the problems. For adding and subtracting, you also have it here as well. Okay, so I just went over the entire document. I did skip over certain